Okay, so it gives you the definition, okay, of the radical. Simply means it's the square root or the nth root. They can be rational or irrational. Rational is what we want because those give us integer numbers, ending decimals, positives, negatives, so on. If it's irrational, it cannot be represented as an integer or decimal, so it's left. Okay, so if we have those prime numbers that we talked about last time, especially, we're going to leave those. Because we don't want decimals, that's the whole point. Okay, so, if you look at an example here, we already talked about that one with the 45, so look at your 18. What can we multiply together to get 18? 9 times 2. Are either of those prime? 2 is. But 9's not. So I have to break 9 down to 3 times 3. But now it's prime. Okay, so that's what we're looking for. Once you have it broken down, if you want to think about it, this is all still under here. What's the only one that has a pair? 3. So if we're looking for the pairs right there, I'm going to take one of those and put it out front. The 2, it's an extra. So we're going to lay it right there. It's kind of like simplifying fractions in that you still have a fraction. When you simplify radicals, you may still have a radical, but it's in the simplified form. Okay, it's better than writing decimal that goes on forever. Okay, it's a way that's more exact. Y'all will see this more in your quadratic formula, Pythagorean theorem, sine, cosine, tangent, all those type things. You're going to use radicals. Okay, so 24. So if we have 12 times 2, 2 is prime. What do we break 12 into?
6 times 2.
6 times 2. Some people say 4 and 3. Doesn't matter. We have 6 times 2. 2 is prime. At 6, we still have 3 times 2. So, if I write my prime factorization, write it all out. We've got 2 times 2 times 2, and then times 3. So we're looking for pairs. Okay. So we have one pair. We're going to take of that pair, we're going to take that 2 out front, and we have to leave the other inside. What's 2 times 3?
4.
2 times 2 is 4. 2 times 3 is 6. So you have 2 squared to 6. You can always check these. You want to make sure that whatever's left inside here is a prime number. And you should be able to go back to your calculator, put in square root of 24 and 2 square roots of 6, and it should be the same number. If it's not, you need to go back and check and see what you've left out here. Okay, so 32. What's up 32? 16 times 2. Let me say something real quick about this one. 16 times 2. 16 on this list. What's the square root of 16? 4. So, I'm saying that you could go straight to this. Okay? Because if it's on this list, you can take the square root. We're going to get the same thing if we keep going. We can say 8 times 2, 4 times 2, and 2 times 2, which means you have the square root of 1, 2, 3, 4, 5 of those. So if we think about all these written out, we want to look at our pairs. We have 2 pairs. One of each of those has to come out front. So in front, I'm going to mark out one, keep one out front, mark out the other one, keep it out front. We had one extra one left over. Well, what's 2 times 2? 4. Yeah. So, you don't have to use square roots, but if you recognize that, it makes it a little bit faster. And some of you that memorize a little bit better, then if you think about things and you can pick one of them, then it's going to go a lot faster. Because you can simply say, this was under the square root. I can't take the square root of that, it stays. I can take the square root of this, put it up front. Okay, 108. Let's do one more like this. What was give you 108?
9 times 11.
9 times 11?
No.
9 times 12. 9 times 12. Okay, we could have said 36 times 3. Get straight to our answer. But if we break this down, we have 3 times 3. They're both prime. 12, we have 4 times 3. And 2 times 2. No matter what you start with, you should end up with that same set of numbers. That if you multiply these back together, you're going to get that. I'm missing the 2 somewhere. So, think of it, look at your pairs. We have 2's and we have 3's. So what's going to be out front?
2 and 3.
A 2 and a 3. Remember they're factors, so they're multiplied together. The extra one here has to stay inside. So what's 2 times 3?
6.
Times 6 square root of 3. If you had looked at the list and you had thought about 36, square root of 36, 6. Square root of 3 has to stay. So, the shortcut, if you know your perfect squares. Okay, now, looking at those perfect squares, if you know these or you recognize these, save yourself a lot of work. Is 36 on this list?
Yes.
What's the square root of 36?
4. Wait, no.
6. Square root means what multiplies by itself to get that number. So the square root of 36 is simply 6. You're done. Square root of 39. What multiplies to give us 39?
3 times
3 times 13 is going to be it, other than 1 and 39. And 3 and 13, if we look at those numbers, are they both prime?
3. Yeah.
So it can't be broken down anymore. So this is one of those that's irrational. If these go to prime numbers and it can't be broken down anymore, we simply have to leave it. Square root of 39. Okay, let me caution you about something that comes up often. We're going to take number 5 here as a good example. When you're finding square roots, when you get your answer, if you can take the square root, you do not put the sign on your answer. A lot of times, this is what I end up with, is that as an answer. If you go to your calculator and you put in square root of 36, and you press enter, it's going to tell you 6. There is no sign on it. We do not want a sign on that answer. It's the same thing when you go to addition. I know that when we add and subtract, we can get a positive or negative number. But when I say what is 8 plus 3, what do you say? 8 plus 3.
11.
11. You don't say add 11. Okay? If I say what is 8 times 3, what do you say?
24.
I don't say times 24. I give the answer. This sign right here is the operation. It's saying we've had add, subtract, multiply, divide. Now we have square root. So once you do the operation, you don't have that anymore. So if I'm going to say the square root of 16, what's my answer? So the square root of 16. 4. What's the square root of 25? 5. What's the square root of 100?
10.
10. If you can take the square root, there is no sign on your answer. The only time that we leave a sign on the answer is if it is a prime number and I can't take the square root of it. You understand what I'm saying? This comes out way more often than it should. Unless you cannot take the square root, you do not have that on your answer, okay? You simply leave it. Okay. Flip paper over. Sometimes radicals are coefficients. We talked about coefficients before. These are numbers that are in front of letters, signs, whatever. Any factor that's brought out has to be multiplied by. Show a real easy way not to forget. We look at number 7. You have 6 square roots of 75. What makes up 75? You have 75. We can say the easiest will be quarters, okay? 25 times 3. 3 is prime. Okay, 25 breaks up into 5 times 5. Those are prime. This is how you can avoid your mistake. Rewrite what you started with that factorization. So, we have 6 out front. Square root. 3 times 5 times 5. What's our pair? 5. So, I'm going to mark that out, but one of those has to come out front. Write it with your 6 times your 6. So what's 6 times 5?
30.
We have 30 square roots of 30. Whatever's out here, you have to multiply it by all the factors you bring out. And the best way not to forget it is to write it down. You could even keep it out here 6 times, whatever it is you're doing, all the way down, so you don't forget it. Okay, same thing over here for 28. I'm going to keep the negative 2. What can we break 28 up into? 7 times 4. 7's prime. So 4 is 2 times 2. Those are prime. So I have 2 times 2 times 7. Here's our pair. So that marks out. I bring the 2 out front. So what are we going to have on the outside? Negative 4 and 7 inside. Very good. And again, check your answers. Use your calculator. Put in negative 2 times the square root of 28, see what you get. It's going to be decimal, whatever, but see what you get. Put in negative 4 square root of 7, see what you get. They should be the same thing. This is the same as reducing a fraction. 100 over 200 is the same as 3 over 6 when you reduce it. Okay, they look different, but the value is the same. These look different, but the value should be the same. Okay?